Hi friends, once again welcome back in our educational channel, that is Precise Electronics. Friends, in previous lecture we had studied clock D flip-flop. D means data, it is a data flip-flop, and in this flip-flop the clock pulse is applied. The clock pulse is used to synchronize the sequence of operation in sequential logic circuit. In this video lecture, we are going to study the concept of preset and clear. What is preset? Pre means preliminary, previous. Preset, that means before applying any pulse, that is either set pulse or reset pulse, the flip-flop is in set mode. Then it is a preset mode. And when it is in clear mode, that means a number stored or the bit stored in that flip-flop is low, it is in clear mode. That means before applying any pulse, the output of flip-flop remains low. This flip-flop, this stage is known as clear state. Why preset and clear pulse are required? Because when the power supply is switched on, that means when a supply potential is connected to the logic circuit, to that flip-flops, at the initial stage, that means before applying any pulses, the output of flip-flop is either high or low. What is the exact output? We are not able to predict that state or that stage. It is either high or low. But there are many applications. In which before applying any pulse, the flip-flop may be at set mode, that is at high mode, or the number or bit stored should be high, or the bit stored should be low. And that high mode or low mode, the high state or low state, is applied by using two special inputs, two special triggers, and these triggers or these inputs are known as preset and the clear inputs. And in this video lecture, we are going to study how that preset and clear pulse are applied to the flip-flop. The constructional diagram or the logic diagram of preset and clear pulse is now going to be displayed on your screen. From this diagram, it is clear that the set and reset input, that is S and R, are applied to AND gate, and the clock pulse is common to both these AND gates. The output of AND gate drives the set and reset terminals of RS flip-flop through OR gate. The one more gate is used in this case, in this circuit. This gate is OR gate. Why OR gate is used? Because in case of OR gate, when one of the input is high, output of this gate is high. So output of upper AND gate, that is a set input, is connected to upper OR gate, and output of lower AND gate, that is a reset input, is connected to input terminal of lower OR gate. And the other inputs, that is a preset input, is applied to upper OR gate, and clear input is applied to lower OR gate. Output of upper OR gate drives the set terminal of RS flip-flop, and output of lower OR gate drives the reset terminal of RS flip-flop. So this is our logic diagram, how the preset and clear pulse are applied to the flip-flop. Friends, there are two modes to apply the preset or clear pulse, and that two modes are active high mode or active low mode. First of all, we are going to study the active high preset and active high clear inputs. When preset and clear inputs are low, and clock pulse and trigger pulses, that is set and reset inputs, are not applied. That means in this case, trigger pulses are not applied to this flip-flop. That means preset pulse is not applied, clear is not applied, set is not applied, and reset is not applied, as well as clock pulse is not applied. So at this stage, the flip-flop is in inactive mode. It is not in active mode. Now, when preset pulse is applied, that means when the preset input is high, it is active high. When preset pulse is high, the output of upper OR gate becomes high. clock pulse, set pulse and reset pulse are still not applied. We are only applying a preset pulse. That means when the preset input is high, the output of upper OR gate becomes high, which is connected to the set terminus, and due to which the flip-flop goes into set. So output of flip-flop is now Q or Y, that becomes 1. Next, active high clear. First condition, that is active high preset. Now we have to apply a clear pulse. That means when the clear pulse is high and the remaining inputs are not applied, the output of lower OR gate becomes high. Only the clear pulse is applied and the remaining inputs are not applied. So due to which the output of lower OR gate becomes high. That means the reset pulse is applied to the flip-flop and flip-flop is now in reset mode. That means from these two conditions, this two statement is clear that when only the preset pulse is applied, the flip-flop goes into the set mode, it is goes into preset mode, the output becomes high, and when we are applying only the clear pulse, the flip-flop goes into clear mode and output goes to low level. That means clear pulse becomes high. The next conditions are when both preset and clear inputs are high. When both preset and clear inputs are high, both set and reset inputs are high, and output at this stage is unpredictable. So this state is not allowed. That means we are not going to apply both the preset and clear pulse at a time. If we want to make the flip-flop preset, then only preset pulse is applied. If we want to make the flip-flop clear, then only the clear pulse is applied. That means by using this preset and clear pulse, the flip-flop is either in preset mode or in clear mode. And after that, as per the clock input, when the clock input is high, first when the clock input is low, flip-flop is in a disable mode. So the flip-flop remains in last state. When the clock input is high, the flip-flop is in enable mode, and as per the control inputs, as per the data inputs, or as per the set and reset input, the flip-flop goes into set mode, reset mode, or is in last state. The actual truth table of this active high preset and clear pulse is now going to be displayed on your screen. From it is clear that when the preset pulse is low, clear pulse is high. That means flip-flop is in clear mode, due to which the output, that is the Q complement, becomes 1. In this case, clock, set input and reset input are in don't care state. When preset pulse is high, clock pulse is low, the remaining inputs are in don't care state, the flip-flop goes into set mode because the preset pulse is up. And after that, the clock pulse and the set of inputs are applied, that is set and reset, and as per the clock pulse and as per the inputs, the flip-flop goes into the set mode or goes into reset mode, or it goes into race mode. That means when clock is high and both set and resets are applied, the flip-flop goes into race mode. That is active high preset and active high clear pulse. The next, that is active low preset and clear. The active low preset and clear, in this case, the NOT gate is connected between the preset input and OR gate, similarly between the clear input and lower OR gate. That means the preset and clear pulse are applied to this circuit, applied to this flip-flop through inverter, and that's why it is active low preset and low clear. When both, first condition, when both preset and clear are low, the actual input applied to the OR gate R becomes high, due to which both set and reset inputs of RS flip-flop goes to high level. What is the condition? When both preset and clear are low, but due to inverter, the actual input connected to the OR gate goes to a high level, due to which the output of both these OR gate goes to high level, and that means the set and reset pulse are applied, and the flip-flop goes into race condition, and this condition, this state is not allowed. That means in this case, in active low preset, both preset and clear at low level is not allowed. Similar to active high, both preset and clear pulse are at high level or not. The next condition, that is when preset input is low, clear input is 1. When a preset input is low, the input connected to the upper OR gate, that is a preset input connected to the upper OR gate now becomes high. That is connected through the NOT gate, connected through the inverter. While the input applied, that is a clear input applied to the lower OR gate, goes to low level. Hence the output of upper OR gate goes to high level. That means in this case the set pulse is applied, and due to set pulse the output of flip-flop goes into set. That means in this case when the preset input is low, the flip-flop goes into set mode. That means preset pulse is applied. Similarly, when clear input is low and preset input is high, when clear input is low, preset input is high, now the lower OR gate is in enable mode. It passes that pulse because that low pulse is converted to the high pulse, and the high pulse is applied to the reset terminal of RS flip-flop, and flip-flop goes into reset. Next, when both preset and clear pulse is applied, when both preset and clear pulse are high, the inputs applied to both this OR gate goes to low level, so output of both this OR gate is low. So flip-flop at this stage is inactive. It is not able to state the output. So as per the preset and clear pulse, the flip-flop goes into set mode or goes into clear mode, and then after that set and reset mode, that is the initial stage, then we are going to apply the clock pulse and the set input and the reset input. And as per the input, the flip-flop once again goes into the set mode or goes into the reset mode. The truth table of active, low, preset and clear is now going to be displayed on your screen. Once again, there is a preset input, clear input, clock, set and reset. When preset input is high, clear input is low, flip-flop is in clear mode because it is active low preset and active low clear. That means when the clear input is low, the flip-flop is in reset mode. So Q bar or Q complement goes to high level, flip-flop is in reset. When preset input is low, clear input is high, the flip-flop goes into set mode. It is in preset mode, so output Q becomes 1 and Q complement is 0. In both this stage, the remaining inputs are in don't care state. That means we are not applying any input, that is a clock input, set input and reset inputs. Next, preset and clear pulse are high. The flip-flop is in inactive mode, but as per the control inputs, that is as per the clock pulse and as per the set and reset pulse, the flip-flop goes into last state, set mode, reset mode or in race condition. That is concept of preset and clear. The symbol of active, low, preset and clear. The symbol of active, low, preset and clear is now going to be displayed on your screen. In this symbol, there is a bubble. The input, that is a preset and clear, are applied. That is applied from the from top side and from the bottom side, from the upper end and towards the lower end of the flip-flop. The inputs are connected. The preset pulse is applied through bubble. The bubble is there and bubble indicates the NOT gate. Bubble indicates the active low. So this is a symbol of active low, preset and clear pulse. The set inputs are there, reset input is there, the clock input is used for the synchronization of operation, and the preset and clear pulse are used to make the flip-flop preset or clear at the initial stage. That is preset and clear. So friends, thanks for watching this video lecture. In next video lecture, we are going to study the concept of edge trigger and edge triggered flip-flops. So friends, thanks for watching this video lecture. Bye. Take care. See you again.